Hello, this is the Exam 2 review slides for summer 2017. For that, so once again, these are the free answer portions of the that you'll see on the exam. With that, so the multiple choice are going to be a lot of the similar to Exam 1, with a lot of the primary topics, sort of fundamental knowledge, things like that. So with that, so first up, so we're going to talk about, we're not going to go into this into great detail. There's actually, in the slide deck that's offered, because Chapter 4 slide deck, also in this one at the very end, there's a bunch of review on this for naming them, but you're going to get things like an alkane, alkene, alkyne, cycloalkane, alkenes, a haloalkane, and an alcohol. So I'm going to draw a structure, and you need to be able to name it, stuff like that. So you're going to see, basically, you sort of assume that I'm going to give you one of each one of these, stuff like that, and so you're going to need to work through those, stuff like that. So. So there's not very much practice on the top hat homework, but the Blackboard homework, there's a lot of examples on that. So I would very much encourage you to work through those. I am going to do a couple where you have to draw the molecule from the name for that. So when we do that, the easiest thing is to start here at the main chain and work your way backwards. So with cyclohex, so your main chain is going to be cyclohexane. So it's going to be, just draw this. The nice thing with the cyclos is you can put the numbering, you start the numberings wherever you want. So it's, just for for ease, we can start the numbering 1, 2, 3, 4, 5, 6. Right. So at carbon 1, we're going to put a methyl group there. At carbon 2, we're going to put a 2-propyl group. Right. So it's 3 carbons long. But we're going to connect it in through carbon 2 with that. So I don't care if you do skeletal structures. I don't care if you do condensed structures. You could do a mix, like I'm doing, of condensed and skeletals with that. It really doesn't matter. So with that. So whatever you're comfortable with. And then here for bromo. So with that. So hanging off of the carbon 4 is a bromine. There you go. So what do we have? We have a cyclohexane, right? So we have a hexagon here. With that, so off of carbon 4 we have a bromine. Off of carbon 1 we have a methyl. Off of carbon 2 we have a 2-propyl group. So there you go. So there's going to be a question on with cycloalkanes and doing cis and trans configuration, right? So remember, cis is it's either they're both going up or both going down, right? Trans, you're going to have one up, one down, stuff like that. And so take a look at this now. On a cyclopentane, it's pretty easy. So I'll do this configuration, and so both of these are going down, right? Stuff like that. So this is cis. Okay, and so for here, right? Stuff like that. So you can always look for a cyclohexane. You can always look at the way the carbon-carbon bonds are pointed. They're pointing towards the axial. You always have an up and a down, also an axial and equatorial on each carbon and cyclohexane. So since they're pointed down, this is the axial down. So that means the equatorial, there's this hydrogen here that's pointed up. For this one here, again, the carbon-carbon bonds point towards the axial. And so this one here we're pointing up, and so the hydrogen here is that's on it's going to be pointing down. So we're doing up and down, right? So this is trans. So I'm going to ask you about a Newman projection. So it's going to be very simple. Okay, so with that, so something like this, a propane. So it doesn't matter which two you look down with that. So, but what I'm going to ask you is to draw it, say, in the lowest energy state. Okay, so I'm going to draw it through here, right? So with that, and so the front. So this one's going to be the front. This one's going to be in the back. Okay, so the front one has 3 hydrogens on it. 1, 2, 3. Okay. The one coming off the back, it has 2 hydrogens on it. which would be like this, and then this methyl group, CH3. And so this, because it's staggered like this, you're going to want to have it, that's going to be the lowest energy. So if you wanted to put them in the highest energy, say if I asked you that, they would need to be eclipsed. Okay, so hydrogen, hydrogen, hydrogen. And so I'm going to move, say, this CH3 up here, there, and there. And so here, so this is the lowest energy. If I asked you what the highest energy for propane it would be for this one, where they would be all eclipsed, and all of the, if there were more groups on here, you'd be eclipsing with the largest groups right on top of each other. So with that, so dihedral angle, if you want to be a technical, dihedral angle of 0. So with that, so but the lowest, they're all going to be staggered like this. So, but it's going to be fairly simple to draw. So, okay. Next up is calculate the degree of unsaturation. It's also called the index of hydrogen deficiency. So I am going to give you the formula. This is how I'm going to give it to you on the equation sheet with the periodic table. So with that, and so you take a look here. So DOU, right? So 2 times the number of carbons, so that's 8, plus 2. That's just a constant in there. Plus the number of nitrogens, which is right. So that is what here. That's 1, right? Minus the total number of halides. So here we only have 1 halide. It's fluorine, right? So minus 1. Minus the number of hydrogens, which in this case again is 8. Okay, all divided by 2. So you've got 16, 18, 19. Yes, 19. Yep. Minus, combine these two, would be minus 9 over 2. So it's 10 over 2, which is 5. So there you go. Okay, so I'm going to give you a couple molecules where it's find the chiral center of the molecule. If the molecule doesn't contain a chiral center, write a chiral. I can't just have you leave it blank, because then I would think that you didn't do anything. But if you find it, a chiral, just write that. Okay. So what you're going to want to do, the easiest way, I think, to do this is to go ahead and sort of draw the condensed structures like this. And so here there's 3 bonds shown, right? So there's a hydrogen here, right? So 2 bonds shown, so it's CH2. 2 bonds shown, CH2. This one has 3 bonds shown, so it's a CH, right? This one is a CH3 and a CH3. Go ahead and draw this out because it's a little bit easier to see. So for here, right? All the CH2s and all CH3s, they cannot be chiral, right? Because in order to be chiral, you have to have 4 different things on it, 4 different types of things. Okay, so here you got 3 hydrogens, right? So here you got 2 hydrogens. So you can go ahead and eliminate all of these. Go ahead, boom, knock them out. So that just leaves this one and this one. Okay, so for here, right, you have a hydrogen. Right, you have a fluorine. Well, that's good. Now you have a CH2 and a CH2. That is a tie. Okay, so what you do is you then go out one more carbon. Here you got CH2 and a CH3. That means that this side is different than this side, right? And so here are your 4 things. Okay, so there's definitely a chiral center here. Now, is there a chiral center here? Well, let's see. There's a hydrogen, right? There's a hydrogen. There's a CH2, okay, and there's a CH3 and a CH3. Okay, these are the same. Now, normally when we were tied, we'd go out, right, one more, but there's no way to go out, right? There's no further. So once you get to the end of your chain, and they're the same, you stop. And so there's not a chiral center here. So the only chiral center in the molecule is, again, right here. Okay, so determining R and S. Okay, so remember you have to do the priority rules here. So with that, so I'm going to put an arrow saying chiral center right there. So like that, and so right. So the first thing you have to do, right, is take a look at the 4 atoms that are directly bonded to it. So here it's a carbon, here it's a carbon, here it's a carbon, right, and then you have the hydrogen. And so the carbons are heavier than the hydrogen, right? So with that, so they're going to be 1, 2, 3. We don't know them yet, but this is definitely going to be number 4. Okay. Okay. So for here, what we need to do is we need to take a look at the bonds. Okay. So for here, right? So we have 2 carbon-carbon bonds and 2 carbon-oxygen bonds. Okay, for this one, right? This one has 2 carbon-carbon bonds, right? Only 2 bonds are shown, so that means the other 2 have to be carbon-hydrogen. And for here, again, you got 2 carbon-carbon bonds here, 2 bonds that aren't shown, so therefore it's 2 carbon-hydrogen. Right? So you look at the heaviest bond. In this case is carbon-carbon, carbon-carbon, carbon-oxygen. It's the heaviest thing hanging off of it. This is heavier than either one of the carbon-carbon bonds, so this is going to end up being number 1. Okay. Now but for these two, it's a tie, right? So with that, so the heaviest bonds are carbon-carbon, and then there's 2 of them, so you're stuck. So let's go out one more, right? So with that, so we're going to look at this versus this. Okay, so for here, it only has 1 carbon-carbon bond and 2 bonds that aren't shown, so 2 carbon-hydrogen bond, and then this 1 carbon-chlorine bond. Here we have 2 carbon-carbon bonds here and here, and then 2 carbon-hydrogen bonds that I didn't draw in. Okay, so here the heaviest bond is a carbon-chlorine bond. Here it's a carbon-carbon bond. So even though there's 2 of these and only 1 of these, that doesn't matter. This is the heaviest bond, so therefore this wins. And so this is a higher priority than that, so this side ends up being 2. This side ends up being 3. Now at this point, what I usually do is come in and redraw it with just the numbers. That chiral center. It makes it a little bit simpler to see. So this is 1 up here, this is 3, 4, 2. Now you come in here, if you know the steering wheel method, you'll say, oh hey, that's clockwise here, right? So it must be R. The problem is with the steering wheel method, that fourth group has to be going away from you. Okay, and so if we're going to say here, so if this is 1, let's see, how does this go? Okay, it's like this. 1, the blue is 2, the green is 3, and the 4 is coming at you. What you have to do is you have to rotate it like this, and so when that happens, right, so you have to rotate it all the way around, so then the 2 would be over here, 1, 2, the 3 is coming out at you, the green is, and then the 4 is going behind. So notice how now it's going counterclockwise, and so it ends up being an S. Now this is the sort of standard way of teaching it, but it helps with a model kit, but you do have to mentally rotate this around. It's critical that you get this number 4, the lowest priority group, going away from you. Another way that you can do it, okay, is you can do it using your thumbs. Okay, I know it's a little weird, but stuff like that. So what you do is you have your thumbs pointed towards the lowest number set. So in this case, the 4 is on a wedge, so it's coming at you. So the thumbs would have to be like this, okay, coming at you. Now what you do is you start your fingers at where 1 is, okay, and then it goes over here to 2 and 3. So what you do is you try to have your fingertips curl 1, 2, and then around to 3. If you can get from 1 to 2 or 2 to 3, that's fine. Stuff like that. And so you have to have your thumb pointing however 4 is. So here it's on a wedge, so it's coming out at you. So it goes 1 to 2. Right? So notice how your fingertips just curl like this. And since you're on since you're using your left hand, it's sinister, right? So with that, so it's S. So with that, if you try to do that with your right hand, so if it curls with your right hand, it would be R. But notice how your thumb's pointed this way. Your number 1 would be up here. You tried to go this way to go towards the 2, right? This way, 2, right? You break your fingers, right? So with that, so if it curled this way, right, it would be R. But since it's curling with your left hand, your fingertips are curling 1, 2, 3 like this. They are it's S. So about that. So you can do it either way. This one's a little bit more. The thumb method is a little bit more abstract, but the nice thing is you do not have to rotate the molecule. Right here, with the steering wheel method, you have to rotate it, and that can, especially if you don't have a model kit available on your exam, doing that mentally can be a little challenging. So with that, I don't know. I doubt they can use it on the MCAT. So that's why, obviously, they're not going to chop off your hands to be able to, when you go into the MCAT. So you're going to have those available. So with that. So good luck. So with that. So Right, so with that, so if they ask you to next thing, right, calculating enantiomeric excess. So for this one, it's what you do is it's just percent %EE is just the dominant one minus the impurity, right? And so you just subtract them, and so it's 96%. That's it. So with that, so not going to get any harder than that. So last up, with meso compounds, what I'm really trying to do is I'm trying to make you just be able to be aware of them, to be able to recognize them, to be able to draw them. And so all I'm saying is take this molecule, I'm going to give you a molecule, and just add appropriate wedges and dashes wherever you need to in order to make this compound meso. Okay, so probably the easiest way to do this would be to say put them both on the wedges. Okay, now it doesn't matter. I'll be able to figure out what you're doing. Okay, and then once you've made it into the meso compound, what I want you to do is show me where your plane of symmetry is. And so the plane of symmetry is right there. So just put a little dashed line where that new plane of symmetry is, and that's it. So, okay, good luck.